Thanks for watching this screencast. The objective of this screencast is learners will be able to multiply, divide, and simplify monomials and expressions involving powers. So on the screen there is a summary of a lot of the properties of exponents that you learned at the very latest in Algebra 1, probably even before that. The first of which is right here about negative exponents. If you've got a to the negative nth power, it means the same thing as 1 over a to the nth. And it's true the other way as well. 1 over a to the negative nth power is the same as a to the nth power for any real number. Of course, a can't be 0. And this works for any integer n. So for example, if I gave you 3 to the negative 4th power, I would say, well, that's just the same as 1 over 3 to the 4th. And it works the other way too. If you were to take 1 over 5 to the negative 2nd power, you'd say, well, that's the same as 5 halves. It even works if your denominator has a positive power. So 1 over 6 to the 3rd power could be written, if you wanted to, as 6 to the negative 3rd. Now these other properties here all depend on this definition. For a and b that are real numbers and integers m and n, the product of two powers that have the same base. If you have a to the mth power times a to the nth power, the way to simplify that is to just simply write it as a to the m plus n. If you're dividing, if you have a quotient of two powers with the same base, a to the mth power divided by a to the nth is simply a to the m minus n power. And of course, that doesn't work unless a is not 0. If a is 0, you've got 0 to any integer power, which is 0, and you're dividing by 0. A power to a power, if a to the mth is taken to the nth power, that's a to the m times n power. The power of a product, if you have a product of two things that are raised to the power of m, you can simply take each of those factors and raise them to the nth power. Here's the power of a quotient. If you have a quotient, a divided by b, or a over b to the nth power, you can simply take the numerator and denominator to the nth powers. And again, in this case, b can't be 0, because if it was, you're dividing by 0. And for negative exponents, if you have a fraction or a division, a quotient, that is raised to the negative nth power, you could flip that order of the numerator and denominator and change the power of the sign of the exponent. So a over b to the negative nth power is the same as b over a to the positive nth power. And in this example, this doesn't work unless a and b are both not 0. Because if b were 0, this would be a nonsense value and an undefined value. And if a were 0, this would be an undefined value. Okay, let's take a look at a couple of examples where we're going to need to apply these. Simplify. It says assume no variable equals 0. Before we do, let's talk about what simplify means. Simplify means a variety of things. It means no negative exponents. It means no repeated bases. In other words, like, you wouldn't want a base of x to show up two different places in your answer. And it means no powers to powers left. No powers to other powers. So we wouldn't say we are simplifying if we had x squared, that whole thing to the 3rd power. So let's take a look at this example here. This is 3m to the 4th n to the negative 2nd times negative 5mn, that whole thing squared. A really wise thing to do first would be to look at anything that uses that power of a property product, which this second factor does. This whole thing is squared. Let's go ahead and do that. Let's square every factor of this. Negative 5 squared is positive 25. M squared is, well, m squared. And n squared is n squared. If you think about that like the order of operations idea, that you wanted to deal with exponents first, well, that seems like a really smart way to do it to me. If you see a power to a power, that's a good place to start. So now, after having applied that property, we've got 3m to the fourth n to the negative second times 25m squared n squared. So now we can multiply these two monomials together by multiplying the coefficients. 3 times 25 is 75. We've got m to the fourth times m squared, that would make m to the sixth. And n to the negative second times n to the second is n to the 0th power. Now, there's one more thing I think I need to take care of here. And it wasn't directly addressed in the previous slide, so I'm glad it came up here. What is anything to the 0th power? It's 1. So n to the 0th power here is just 1. All this it really is 75 m to the 6th times 1. This is just 75 m to the 6th. If you end up with the 0 as one of your exponents, that base to the 0th power is 1. Here's another example. We've got x squared y all over xy cubed, the whole thing squared. For a good first step here, I would recommend maybe writing this as the numerator squared over the denominator squared. X squared y squared over xy cubed squared. And then what you can do now is you can apply that power to another power rule, both for the numerator and the denominator. So for x squared y squared, I can square both of those to get x to the fourth and y to the second. In the denominator, I can square x and y cubed by getting, or to get x squared and y to the sixth. And what I can do now is I can apply the rules for dividing like bases. X to the fourth divided by x to the second is going to be x squared. I often will look at the problem where I'm dividing two monomials now, and I'll say, you know, for each of those, I want to decide where the leftover bases will be and how many of them there will be. So x to the fourth divided by x squared will leave me with an x squared in the numerator, because I started with more x's there. But y squared divided by y to the sixth is going to leave 4 y's left over, multiplied together, in the denominator. So I need y to the fourth on bottom. And I'm simplified. Okay, here are a couple of items for you to try. Hit pause, give them a shot, and when you think you've got some progress, hit play to get some feedback. Let's talk about it. I'm looking at this example of 4j times negative j to the negative second k squared times 3j cubed k to the negative seventh. I don't see any powers to another power here, so all I think I need to do is think about multiplying. And the first thing I'd like to do is multiply the coefficients of each factor. 4 times this is a negative 1 times 3 makes negative 12. 4 times negative 1 times 3 is negative 12. You know, j here is really j to the first, isn't it? And if it helps you to rewrite it that way, then I would say go for it. So if I multiply my j's, I've got j to the first times j to the negative second, which times j to the third. And my rule is to add all of those exponents. 1 plus 3 is 4, 4 plus a negative 2 is 2, that's j squared. And for the k's, I've got k squared times k to the negative seventh. That would be k to the negative fifth. Now I've combined everything. I only have one base with one exponent for each base, but I'm not okay with the k to the negative fifth in my answer. So I need to remember that k to the negative fifth means 1 over k to the fifth. I need to write my answer like negative 12 j squared all over k to the fifth power. This example, which is not an easy example, has two different powers to a power. I'd like to simplify those first. So let's think about negative m to the fourth cubed. You know, I really need to cube both the negative 1 and the m to the fourth here. So negative 1 cubed is negative 1 times negative 1 times negative 1. And that is negative 1. So I'm going to get negative 1 times whatever m to the fourth cubed is. That's m to the 12th. On bottom, well, I've got 2 to the negative second power. And I need m to the second to the negative second power. That would be m to the negative fourth power. So what I want to think about here is how to deal with the things that have negative exponents in them. And the way to deal with that is to move them into the numerator and change the signs. So when I rewrite what I have, I've got my negative 1. I'm going to get 2 squared on top now. The 2 to the negative second belongs as 2 squared on top. I've got my m to the 12th that was there in the previous step. And I've got an m to the 4th that showed up there because I had to move the m to the negative 4th out of the denominator. So in simplifying this, I'm going to get negative 2 squared is 4. And I can combine these two m terms that are multiplied together by adding their exponents. M to the 16th. This should say negative 4 m to the 16th. Thanks for watching.